And both sides, when you have what alkyl groups, that will be ketone actually, right? So let me see this one in these slides here. Aldehydes. See, one side is what hydrogen, other side is what alkyl group. Now this is called what aldehyde. But when you have like this RC double bond OH. Now this is called what carboxylic acid, correct? So this we are not discussing today. So this is C double. I can write like this also, but RCHO also. Both are same. RCHO or RC double bond OH. Both are same bit, right? Now, for example, if I take what happened, this is formaldehyde. See, now you may ask, sir, here also hydrogen is there. Yes, this is the lowest aldehyde, lowest number aldehyde. That is called formaldehyde. How many carbons are there? One carbon, methane because alkane, and you have write aldehyde, Al. All for what? Aldehyde. Ethanol is the IUPAC nomenclature. Formaldehyde is the lowest one in the aldehydes, right? Next, this one is acetaldehyde, CH3, C double bond OH. This is the alkyl group, R group, and this one is the hydrogen group. The name of this one is acetaldehyde group. Acetaldehyde it is. Acetaldehyde, common name it is. I think everyone knows this one. Eth, ane, al, ethanol. Eth, two carbons, ane, alkane, single bond they are having, isn't it? Don't consider this pi bond. This pi bond on the functional group. The pi bond, if it is on functional group, no need to consider it. Pi bond is on carbons, alkane chain. In this, if you have any pi bond, in this R, if you have any pi bond, then it called as ene. So if you don't have any pi bond in R group here, if you don't have any pi bond, that will be called alkanes only. So ane, aldehyde, ethanol it is. In this way, we can write many number of examples here. Yes? Correct or not? Right. You can also write RCHO also. Okay. Next, we'll see the ketones here. Now, here also you are getting what? In the place of hydrogen, also we are getting one more R. It may be same or different. These two may be same, may be different also. Isn't it? Like that we get here. If they are same, we call simple ketones. If they are different, they are called mixed ketones. You see, both are what? Same alkyl group. This is called simple ketone, we can call this one. Acetone, we have to call this one. Otherwise, what happened? How many carbons are there? Probe is a common name. 3 carbons are there, probe. Now, in alkane chain, you have any pi bonds? In alkane chain, no pi bonds, therefore ane. And for ketone, the nomenclature we are writing, secondary suffix we are writing on, propanone. IUPAC nomenclature is the propanone. It is. Correct? Understood? Now, if you observe what happened, next one. Now, in this case, total number of carbons, how many better? 2, 3, 4 carbons are there. So, for our understand, I am writing like this, CH3, C double bond O, C2H5 we can also write like this also. C2H5 we can also write like this also. So now it will be what actually? Butanone. It will be what? Butanone. That is the IUPAC. What is the common name? This one is a ethyl group. This one is a methyl group. So methyl, ethyl. Alphabetical order E comes first. So ethyl. This one is a methyl. Ethyl, methyl ketone. Right? Ethyl, just like ethers. It is also given same like ethyl methyl ketone. So generally it is called what? Butanone. We have to call this one butanone. Here no need to give any numbering. Why? Because if you start from here also 2 weak. For example, if I write like this CH3 CH2 C double bond O CS, both are same. We can give numbering in any direction. 2 butanone only we are getting. If we give numbering in this direction, what butanone we are getting? 2 butanone only we are getting here. Both the case we are getting what? 2 butanone. In that case, no need to give any nomenclatures here, right? What is the common in this case? C double bond O is common. C double bond O is common in both the case. It is called what? Carbonyl group. This group is called what? Carbonyl group. If it is having hydrogen at this side, aldehyde. You have R group at this side, that is called what? Ketone. This is the primary information, basic information, isn't it? Everyone should know this one. Very simple concept there actually. Now in this, they are containing which group? C double bond O group they are containing. We can write they are carbonyl compounds. They can be called as carbonyl compound. And general formula will be CnH2nO. This is the general formula. Remember the general formula. CnH2nO is the general formula for both aldehydes and ketones. They are having same molecular formula. Both aldehydes and ketones are functional isomers. Their functional groups are same, but they're having, their functional group is what? Different, but they're having what? Same molecular formula. Molecular formula is same, but the functional group is different. They are called functional isomers. Example, aldehydes, ketones are functional isomers. Now, if you observe what happened, carboxylic acids. Carboxylic acids can be written like RCOOH. RCOOH. Now, this OH part will replace with various groups like halogens, ester groups, ether groups, amide groups like that. To give what different type of compound. They are called derivatives of carboxylic acid. But you cannot call RC double bond OH or RC double bond OR cannot be called derivatives of carboxylic acid. Carbonyl compounds are not at all called derivatives of carboxylic acid. Why? Because if you observe what happened in this OH group, you are replacing it. RC double bond OH group, you are replacing with what group actually? Again with oxygen only. Again with oxygen. Again with what happened? Another element actually. But here we are placing only hydrogen alkyl groups here. So that is the reason. Remember, they are not called derivatives of carboxylic acids. Now this is a, you can identify easily. Now you observe here what happened. Now in the place of OH, what I am writing? Halogen I am writing like X means fluorine, chlorine, bromine, and these are called acid halides. We can call this one acid halides. So in carboxylic acid, if OH is replaced with halogen, they are called acid halides. Right? Next, if you replace OH with what? This unhyded group, if we replace what happened? OC double bond or they are called unhydrates. Acid unhydrates they are called actually. Next, if you replace this one with OR group here, OH is replacing with OR, they are called what? Esters, isn't it? They are called what? Ester groups. Very, very important ester it is. And finally, if you replace this with NH2 group, they are called what? Amides. RC double bond when they are called amides. So if you replace with NH2, they are called what? Amides. If you replace with OR dash, isn't they are called what? OR, not dash, OR actually. Ester it is. If it is replaced with RC double bond O, they are called anhydrates. If replaced with halogen, they are called what? Acid halides. So acid halides, acid anhydrates, esters, acid amides. This we'll discuss separately in the carboxylic acids later. All these are actually acid derivatives. Now, when you observe what happened, when it is derived with RC double bond O group, RC double bond O group, they are called acyl derivatives. They are called acyl derivatives. So that we don't discuss here. Let me leave it that one. So we'll see now what carbonyl group separately we are discussing here. Carbonyl groups actually. Now, when you observe what happened, what is the hybridization of the carbon in the carbonyl group? Because of having a pi bond, definitely this is called what? sp2 hybridization. So the carbon present in the carbonyl group always is having sp2 hybridization. It has attached to a double bond oxygen here. So for example, RC double bond OH. So one pi bond is there. Therefore, it is sp2 hybridization. Okay. Now there is this oxygen will have a two lone pairs here like this. So one sigma bond here. This is one sigma bond. One is pi bond. Now carbon will have tetravalence. Why? Because if you observe what happened, this one R H. Now carbon is having how many valency bonds? Better 2, 3, 4. So carbon is having tetravalency, but oxygen is having what? Only divalency it is having, right? Like this it is having. Important thing if you observe what happened here. Very important thing if you observe what happened. The bond angle here is 120 degrees. Why? Because hybridization, when you observe sp2, will have 120 degrees only. The hybridization, if you have sp2, definitely the bond angle must be what? 120 degrees. And the geometry, the shape, whenever if you have sp2 hybridization, the bond angle will be 120 degrees and the bond shape will be trigonal pair. For not only this one, for any sp2 hybridization carbon, the shape will be what? Trigonal planar. Trigonal planar means you place what happened here. It is a plane. Okay. One thing here, other is here like this. All are in same plane only. Same plane only. This is on left side, right side, this is on here like this. Can you explain this better? Aldehydes ketones have which group in common?
Carbonyl.
Yeah, very good. Find a group of compounds which have a carbonyl group like aldehydes and ketones, which is having aldehyde groups. Group of compound having carbonyl group actually. Acid halides RC double bond O X. Alcohols ROH. Acid anhydrides RC double bond O OC double bond O. Again, what happened? R. Phenols. Now tell me the answer better. Which is having just like what happened in carbonyl groups. Which is having here? Which is having better?
Acid anhydrides.
Why? Because you observe what C double bond O group. C double bond O group is there. Here also C double bond O group is there. So you can take even this one also answer you can take. But these two are actually derivatives of carboxylic acids. They are not like what? They are looks like carbon compound, but they are derivatives of what? Carboxylic acids. What is the hybridization of carbon atom in carbon group?
sp2.
Right, very good. Next, isomerism present in the aldehydes and ketone also let me see now here. Isomerism in aldehydes and ketones here. What is the isomerism present in the aldehydes and ketones here? Now, when you observe here, what happened? First thing is chain isomerism. These are not chain isomerism. So for this compulsory, the aldehyde must have 4 carbon atoms, 4 or more carbon atoms. Must to have at least what happened? Greater than or equal to 4 atoms. Then only it can show what happened? Chain isomerism. For ketones, it should have what? Greater than or equal to 5 carbon atoms. That means if I write like this, formaldehyde, okay, acetaldehyde, okay, propanaldehyde. Do they show chain isomerism? No. They do not show chain isomerism. Why? Because for exhibiting chain isomerism, we should have more than or equal to 4 carbon atoms. Here only 1 is there, here 2 are there, here 3 is there. They do not show chain isomerism. Now, which is starting molecule? See this one. A starting molecule will be at least 4 carbons you should have. So this one will be the first thing. You see the name of this one, anybody? It's possible. IUPAC name only I'm asking.
Butanol.
Butanol, right? Now what is the chain isomerism? How we write the chain isomerism? Like this also we can write here. We can put one methyl group like this. We can put a methyl group here. Now this is the chain isomer. Why? Because the parent chain here containing how many carbons beta? 4 carbons. The parent chain, the main chain, the backbone of the chain is nothing having 3 carbons. Now these two are what? Chain isomers, and both are having molecular formula will be C4H8O formula they are having. Right? Now this is called 2-methyl propanol. Why? Because you see here number 1, number 2, number 3. Second carbon is having methyl group, therefore 2-methyl propanol it is. Right? We'll take some more examples also here. We'll take 5 carbons here. Now you can write one straight chain, and you can write what? Some branches here. Or you can make this methyl group here also. In second position we can make, even third position also we can make. 3-methyl butane also we can write here. Like this also. This is what actually first carbon, second carbon, third carbon, fourth carbon. This is called 3-methyl butane. So as number of carbons are increasing, we get more number of chain isomers. One is straight chain, N-pentanol, a straight chain. So next case what happened? The methyl group on second carbon. Like next what happened? Methyl group on third carbon. Can you put methyl group on fourth carbon? Is it possible? What happens if I put methyl on fourth carbon? Which molecule, which structure we get actually?
N-pentanol.
Again, we get N-pentanol only. So in that case, what happened? It can show what happened? These isomers actually. Okay. Now we can show one more thing also. You see, the two methyls we can put on second carbon also. See, the two methyls we can put here second carbon also. In this way also we can put here. Now, if you observe here what happened, one thing you have to observe here. Either all the chain isomers, let me see here. So how many carbons are there in the parent chain? Better. How many carbons are in the parent chain? 5 carbons are there. Here?
4.
4 here?
4.
Here?
3.
Now if you observe what happened, if I take this is N-pentanol, this one, N-pentanol and 2-methyl-butanol, these two are chain isomers. Okay. But 3-methyl-butanol and 4-methyl-butanol, they are not called chain isomers. They are called positional isomers. Why I said like this? Any reason?
In chain isomer, word root should be changed.
Root word must be same. The number of carbons must be same in parent chain. The root word must be same. When the root word is same at what actually they are not called chain isomers. But when they are having same root word, same number of carbons in the parent chain, but the position of the substituent is different. The position of substituent is 2 here. The position of substituent is what? 3 here. Therefore, they are called position isomers. So what I am saying here, 2-methyl-butanol, 3-methyl-butanol are not at all called chain isomers. They are called what? Position isomers. But N-pentanol and these two are chain isomers. Because you observe this one, name is this one is a 2,3 dimethyl. 2,3, already named it. 2,2 dimethyl propanol. Now these two are actually chain isomers because it has 5 carbons are there, it has what? 3 carbons are there. Now these two also chain isomers. Right? And these two also chain isomers. Understood here? Any doubts you're having? No doubts?
No, sir.
Yes, we'll move to what next?
No, sir.
Now you try this one. This ketone, you have to try this one. Ketone. 2-pentanone, 3-methyl-butanone. 2 examples we are getting. But C5H10, ketone it is. Pent-but. Okay. You are getting like this actually. Now these two definitely called as chain isomers. Now this one if you observe what happened. Hexane 2,1. Why you are calling hexane 2,1 beta? Total number of carbons are 6 here. Therefore hexane, and between carbon you are finding no pi bond between carbon A, and the second carbon is having that functional group called carbonyl function. Therefore it is called hexane 2,1. And one more we can write like this also with 4 carbons. Writing 4 carbons like this. So 5 carbons. 5 carbons we are writing like this. One more we can write with 4 carbons also we can write. It is also 5 carbons. We'll write with 5 carbons, 4 carbons. If possible, let me see now. CS3, C double bond O, CS3, CS3, CS3. Now how many carbons are there total? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 आ रहे हैं. ये भी है ना? So this also we can write the chain isomers here. Okay. In this way we can write many number of chain isomers like this. Now is it possible for you? Chain isomers of C6H12O. Ex, pent, pent. Now both the case you got pent, pent. Both the case you got the pent, pent. Now do they are called chain isomers? But these two called chain isomers. And these two called chain isomers. So definitely all of the answer will be correct. Why? Because what I am saying, these can be taken as chain isomers, but these two pairs we can't take as a chain isomers. Understood my topic, my point here. These two cannot be taken as a chain isomers, but you can take these two chain isomers, no problem. And these two you can take chain isomers. The answer must be what all of these. Understood here? Any doubts you're having? In this case, chain isomers here. 2-methyl propanol, 3-methyl propanol, 2-ethyl ethanol, none of these. Which is the chain isomer they are asking. 3-methyl propanol is not possible beta. It's impossible to write 3-methyl propanol. See, this is propanol actually. Okay, CH2, CH3. First carbon, second carbon, third. If can you put a methyl group? Is it possible? If I put a methyl group here, now what is the name of this one beta?
Butanol.
Butanol it is. So definitely 3-methyl butanol is not, even 2-ethyl ethanol also not. These two structures may not be possible, cannot be, impossibilities. So answer must be 2-methyl propanol, right? Isomerism in the aldehydes and ketones, functional isomers and positional isomers. Let me see now here. Position isomers, what happened? The position of the aldehyde always will be at the end of the carbon. So you can't change the position of aldehyde. It is impossible. So you can't place what definitely for multifunction what happened you can place, but when you take only one CHO, if you take one CHO, where you have to keep actually? At the end of the only. So that is the reason what happened we don't see. For aromatic aldehyde generally we'll take actually. See, observe this one. Yes, you're observing its position of this one. If you observe 1, 2, next what happened? 1, 3. Next what happened? 1, 4. Right? So this is what happened. They can be taken as positional isomers. So para, meta are what? Positional isomers we can take actually. Metamerism. So one thing, aldehydes do not show metamerism. Remember, because whenever either side of the functional group, when you have carbon chain, both the case if you have carbon chain, then only it will show the metamerism. Either side of the functional group, when you have the carbon chain, then only they show what? Metamerism. So in the aldehydes, we don't have any carbon chain here. So aldehydes do not give metamerism because one side it is not having alkyl group, having what? Hydrogen. So they never show a metamerism. Which one? Aldehyde. So only ketones will show now. If you observe what happened here, at this, both are having molecular formula is what? C5H10O. The first one, second one is having C5H10O here. Okay. Now here, how many carbons are there? 2 carbons here. How many carbons? 2 carbons here. 1 carbon is there here. What? 3 carbons are there. Now you observe what happened. So in either sides, their number of carbons are different here. Therefore, they show what? Metamerism. And you can also call this one position isomers also. Why? Because it is having 3 pentanone. It is called 2 pentanone. Root word is same, pent, but the position of the functional group here what? Third position. The position of the functional group here what? Second position. So these can be also called what? Position isomers also. Isn't it? Can be called as what? Position isomers also. Now, but whenever what happened, metamerism and position will get a combination. Generally, we'll take metamerism as a dominating factor here. Understood here?
Yes, sir.
Functional isomers, if you observe what happened, both aldehydes and ketones are undergo what will give functional isomers actually. Both aldehydes and ketones definitely will have a functional isomers. In addition to this one, you may get enols also or cyclic ethers also. Enols means what happened? CH2 double bond CH2OH like this. Now it is having ene, double bond is there, alcohol is there. Now these also called functional isomers with aldehydes and ketones because these also having same molecular formula. So whichever molecules are having double bond and alcohol group, they are called enols. And cyclic ether means like this. This is cyclic ether, CH2, not ether, cyclic ethers. They also comes under where in the functional isomers. So how many functional isomers are together? We can write aldehydes, ketones, enols, finally what happened? Cyclic ethers. And all these will have same molecular formula. Same molecular formula. What is the difference? Difference in where? Functional group. Difference we are getting where in the functional group. What I am reading this one, same molecular formula they are having, but they are having different functional group here. Now you observe this one. C3H6O. How many types we can write? C3H6O molecular formula. I have taken aldehyde here. I have taken here ketone. Third one we can take enol. This is the enol. We are just now we taken this one. Enol it is. And finally I have taken what? Cyclic ether. Then it. Methoxyethane also. This is also one we can take. Ethene also we can take. Cyclic ether also we can write. Cyclic isomers. This one. You see here. Oxetane we can call. Cyclic ether we can call this. Cyclic oxetane generally we call this. Or 1,3 epoxy. Why? Because first carbon, second carbon, third. Now oxygen linked with first carbon, third carbon. So this oxygen is linked with first and third carbon. Therefore 1,3 epoxy propane we can. Now this will be what? Cyclic ether only, but same molecular formula. It's also cyclic ether only, but what I have done here, one carbon we have taken where? On second carbon, 1,2. Something we can call this one 2-methyl oxyrene, because second carbon is having here what? Methyl. 2-methyl oxyrene. 1,2 epoxy propane. Like this also we can write. So these are the number. This is not in syllabus. You don't have the syllabus. Just you read that only aldehydes, ketones are having functional groups. Remaining you just leave it this one. Remaining are there, not there in the syllabus. Leave it. Only aldehydes, ketones are functional isomers. Now tautomerism is there in the not there in the syllabus, but anyhow it will be useful for you. Just I will explain this one by using some mechanism like this. Let me see the tautomerism. Now, if I take something like this, because it will come in aldol condensation reaction, that is the reason I have taken here CH2 hydrogen C double bond OH. Shall I write like this? Acetaldehyde, same, no? Correct. Now what I am doing, I am putting this bond here. Now this bond is shifted over here. Now the hydrogen shifted where actually here. Now because of this CH2, right? Double bond COH. You're getting hydrogen. This is called what? Vinyl alcohol. This is called what? Acetaldehyde. This is called enol. But generally what happened? This percentage will be less than 1% and this percentage will be 99.9%. This is 0.1%. You can take. This will be 9. That means tautomerism generally happens, but because of the tautomerism, whatever the product we are going to get, that is highly unstable. This is highly unstable because OH on double bond carbon highly unstable. So definitely what happened? Resonance is there, no? It will do some resonance like this here. So again, we get this compound. Tautomerism is not there, but anyhow, we can take that. When you get keto form also same like this. Even keto also same like this. CH2, C double bond O, CH3. Take one hydrogen here, put this one here, and shift the pi bond here, and shift the hydrogen here. You will get this one. Right? It's about the tautomerism, but not there in the syllabus. Leave it this one. maybe आपको इतना जरूरत नहीं है P2 property. Directly I will shift to what nomenclature now. How to give the nomenclature? When you observe the nomenclatures here, the regular name we are giving alkanol. Please all of you observe carefully. Alk, root word, ane for getting primary suffix, single bonds, all functional isomerism. So depend upon number of carbons, we change this alk, but we don't change this one. It's a common for everything. We have to follow the longest chain rule. So the aldehyde must be in the chain. So when you are giving the longest one, that means nomenclature, the aldehyde must be in the parent chain, main chain. Okay. Now we have to follow the alphabetical order. So for example, if you observe this aldehyde is having in which one? Parent chain only, no? The aldehyde group is present on parent chain. The same rules already we number of times we got. Now let me see each and everything. Now tell me the common name for this one, beta. Too fast, beta. Common name for this one.
Formaldehyde.
Formaldehyde. IUPAC name?
Methanol.
Methanol. Very good. Second one. What is the common name? Acetaldehyde. IUPAC name is ethanol. This is called what? Propionaldehyde. 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 This one. But generally we use propanol. This one we generally use. So you have to remember formaldehyde, acetaldehyde compulsory. Next, this is called butyraldehyde. It's called what? Butyraldehyde, isn't it? N for what? Straight chain. N is indicated as straight chain. Butyraldehyde. This is called what? Butanol, isn't it? This is called what? Butanol. Remember this one. Next, pentanol. This is what? Pentanol. Right? Common name will be varaldehyde. Varaldehyde, no need to remember this one. Varaldehyde is not very important for us. This one is first carbon, second carbon. So we can give what actually? Iso nomenclature. No. Iso 12 carbons are how many here? 1, 2, 3, 5. Iso pentanol. Isopentanol, or otherwise called, we can call 2-methyl butanol. First carbon, second carbon, 2-methyl. Now one thing you have to remember, this is a functional group here. This is a functional group. Functional group next carbon is alpha. This carbon is called beta. This carbon is called gamma. So alpha carbon is having methyl. Therefore, alpha methyl, 4 carbons in the parent chain, butyraldehyde. Otherwise, second carbon is having methyl. Therefore, you can write 2-methyl butanol because of 4 carbons. Also, we can write iso because second carbon is having iso. Remaining is a straight chain. So what we can write here? Isopentanol also we can write like this. Now here double bond is there here. Double bond is there. Now in that case what happened? We can give numbering from functional group side here. Second carbon is having what here? Double bond. Therefore total carbons are 3. Pro, in, all. Propinol. Common name is what happened? In this case, acraldehyde, isn't it? Common name, you're having double bond, we can call acrolein or acraldehyde. Acrolein also we can call acraldehyde. And IUPAC name is called propinol. We can call it propinol. Numbering no need to give. If you give no problem. If you don't give also no problem, because the double bond is always on second carbon. You can't place double bond on third carbon. You can't place double bond on the first carbon. So you can write propinol or propitunol. Both are what happened? Same only. Next one, if you observe this one, what? Protonaldehyde, isn't this is called what? Protonaldehyde. This is a common name is called what? Protonaldehyde, isn't it? The common name is called protonaldehyde. IUPAC nomenclature, anybody?
Butanol.
There are 4 carbons are there. But double bond is on second carbon. 2-in, aldehyde is there. So 2-butanol, otherwise but 2-in all, isn't it? But 2-in all, like that. Now some functional groups are there. This is called aldehyde. Otherwise phthalic acid we call. Generally it's a derivative of phthalic acid. If you put what carboxylic here, it is called phthalic acid. But the derivative of this one you can take as aldehyde. It is. But 1,2 position is there. No, first comes second. Benzene 1,2 dicarbaldehyde. Also we can call this one. Now this is called what? Salicyl aldehyde. We got in where? Which reaction we got? Which neighbor reaction we got? Anybody? This product? Which neighbor reaction we got this one?
Remer
Very good.
reaction.
Now, IUPAC common name is salicyl aldehyde. Correct or not? Salicyl aldehyde. There we have taken. IUPAC name will be 2-hydroxy benzaldehyde. 2-hydroxy. This is generally when you write like this, it is called benzaldehyde means what? Benzene having CH4 group is called what? Benzaldehyde. This is called benzaldehyde. Second position you are having OH group. Therefore, first position, second position. In this way, we can write actually. In this case, some more nomenclature, some typical molecules, if you observe what happened, this is called glyceraldehyde. Glyceraldehyde, common name. IUPAC name will be, you see, 2 is having hydroxy group, 3 is also having hydroxy group. But numbering got to start from the aldehyde because aldehydes are more priority than what? Alcohols. So this is alcohol function. But aldehydes will have more priorities than compared with what? Alcohol. So it is called 2,3 dihydroxy. Total number of carbons are how many? 3, therefore propanol it is. If you observe what happened, vanillin we call this one. It is there in the textbook, vanillin. And IUPAC name nomenclature, we have to give numbering from aldehydes only. Why? Because aldehydes are more fatty than ethers and alcohols and phenols. Therefore, 4-hydroxy alphabetical order and 3-methoxy benzaldehyde. Very simple. 4-hydroxy, 3-methoxy benzene. This is methoxy group you have to call. This part is called hydroxy group you have to call. Now this one is very simple. Tol aldehyde. Para because actually we have to place here CHO. Generally, higher priority will place like this actually. CHO here. Here we put CH3. Okay. Para tol aldehyde. Para because this position is para position. That is the reason like this. Otherwise, which position it is? 1, 2, 3, 4. So 4-methyl benzaldehyde. What we can write here? 4-methyl benzaldehyde. We can write here. 4-methyl benzaldehyde. Correct. Nomenclature for the ketones, let me see now. Nomenclature for the ketones. Already I told you this is acetone, also called propanone, because 3 carbons are there, prop. Ane because of single bond between carbon, one because it is a ketone actually. Right? What? Butane to one, ethyl methyl ketone, because ethyl group it is, this one is ethyl group. So ethyl methyl ketone it is. Now diethyl ketone it is. Otherwise, numbering you should give like this: 1, 2, 3, 4, 5. So pentan 3-one, pentan 3-one. We can write like this: pentan 3-one. Otherwise, what happened? Diethyl ketone. Everyone is understood ketones nomenclature. For this one, tell me the common name, beta.
Methyl propyl ketone.
Correct. Very good. Methyl propyl ketone. IUPAC name will be? The IUPAC name?
Pentan 2.
Pentan 2-one. Very good. Pentan 2-one. In this way, we can write n number of examples actually. Now, if you observe what happened, 2-bromo, hexane 3-one. Correct or not? 2-bromo, hexane 3-one, or 3-hexane. Both are correct only. Hexane 3-one, isn't it? Or alpha bromo, because this is a functional group. No, this is alpha carbon, this is also alpha carbon, but alpha is having bromine. So alpha bromo, this part is ethyl group, and this part is what actually? Propyl, right? Propyl group, ethyl group. So actually ethyl propyl ketone, but alpha is having bromine, therefore alpha bromo ethyl propyl ketone actually. Now we got a double bond is there. Now the double bond must be in the root chain. Therefore, what we can take and like this we can take. Numbering we can take like this. Now remember, the numbering we are not giving from this direction. Why? Because if we give from this direction, this is getting how much? 1, 2, 3, 4 we are getting here. So 4 is not correct. No. So in this way we can give here. Now what is the name here? 4-methyl pent 3-ene 2-one. Correct? 4-methyl pent 3-ene 2-one it is. Also called mesithyl oxide. Remember this one? Mesithyl oxide. This will get in the aldol condensation reactions here. There let we see that mesithyl oxide in aldol condensation reaction. Name of reaction, we'll see this. This is already you know this one. Which suffix we use for aldehyde beta?
All.
Very good.
Al.
Can you give IUPAC name of alpha hydroxy butyryl aldehyde? Is it possible for you? But means how many carbons? 4 carbons. Aldehyde, if they say aldehyde always will be on which carbon beta?
Last carbon.
Last carbon or first carbon. Like. Now if it is functional group, this will be alpha carbon. Now alpha is having which group beta? Hydroxy group. Put here.
OH.
Now put here 3, 2 hydrogens, 1 hydrogen. So here 1, 2. So 2 hydroxy butanol. Isn't it? In the IUPAC nomenclatures also. If you know the concept, it will be easy for you. And give the nomenclature beta for this one possible. What rule we have to follow beta in this case? The aldehyde must be in parent chain. The rule is compulsory. The aldehyde must be in parent chain. Aldehyde never taken as a substituent here. Parent chain will come like this. Numbering what always should start from the carbonyl group only. Now tell me better.
2-ethyl, 3-methyl, pentanol.
Alphabetical order you have to follow. 2-ethyl, 3-methyl, pentanol. C will be the correct answer. Protonaldehyde, just now I told you. Anybody remembered protonaldehyde? Just now I told you. Anybody remembered? Because it's very, very important beta. Protonaldehyde we have to call. Now tell me the nomenclature for this one. IUPAC nomenclature for protonaldehyde.
Butanol.
Remaining are not there. How many are there? How many are listening to the class?
Sir, we are there.
You are there, but not responding. Robot, please respond here. What is the name of this one? Remaining one?
Butanol.
इसको बोलने के लिए इतना. Now this is called cinnamaldehyde beta. What is the difference between these two? Here you have methyl group. You are having a phenyl group here. Again, same thing. 1, 2, 3. So we can call this one 3-phenyl. The name of this one is called 3-phenyl. 3-phenyl propanol. Called cinnamaldehyde. Very important. Protonaldehyde and cinnamaldehydes are very, very important. In your notebook, write down these two. Protonaldehyde and cinnamaldehyde. Write down your notebook, all of you. They're very, very important. We'll get in aldol name reaction. What is the IUPAC name of methyl isopropyl ketone? Methyl isopropyl ketone. Isopropyl कैसे लिखते हैं बेटा? This is isopropyl ketone. Methyl isopropyl ketone. Now tell me beta, what is the IUPAC name for this one? नंबर कहां से देना है आपको?
Trimethyl butone.
3-methyl butane 2-1. This is about the IUPAC nomenclatures I have completed. Right? Now you observe here in your textbook what happened. This is the textbook. You have already discussed cinnamaldehyde. Correct or not? Discussed or not?
Yes, sir. Sir.
Yes, sir.
Just a minute. We have it. How many are listening? 37, including me, 35. Who are present today? Let me see. Daily I'm taking attendance beta. I don't send any absentees names in WhatsApp. See, daily I take attendance. We were absent. What happened? It will be reflected on your practical marks. Amruta, Anupama, Bujibaldru, Bhuneshwari, Deva, Harivom, Manjusha, Kiran, Neha M, Neha S. Neha S तो कल तो absent है. Neha S. Idhi, Nikita, Nishant, Parda, Patil Adarsh, Devashish, Prajna, Pranali, Radhika, Rani, Samiksha, Samrin, Samruddhi, Shivani, Shreya, Shreya Paushe, Shreya Sneha, Rupnali, Tejas, Vaishnavi K, Vaishnavi SB, Vaishnavi Vanita P, Varsha, Venkatesh, Vinayak Dop. Vaishnavi VH is absent. Yes, Vaishnavi VH is absent. Nikita Talawar also absent. Let me see later. So let me check your textbook, what they are having. These are the compounds you have taken. Nomenclatures also we completed here. Estaldehyde, benzaldehyde, isn't it? Alpha bromobutylaldehyde, all we have taken. This is beta bromo. Why? Because this is alpha carbon, beta carbon. Like this. Alpha alpha dash, when you use no alpha alpha dash beta beta dash, we will use when you have two sides we have. For example, CH2, C double bond O, CH2, bromine you are having. Here also you are having, in this case, alpha chloro, alpha dash bromo we can call. Both are alpha, no? Because either sides they are connected with carbon function group. So alpha alpha only. So one is alpha, other is called alpha dash. Like beta beta dash we can write it. Now acetophenone, in the last class I told you, acetophenone, benzophenone. Please remember all of you, acetophenone, benzophenone were very, very important. Both benzophenone important. They are very, very important. Practice these two structures. Number of times it will ask in examination. How do you distinguish acetophenone and benzophenone type questions? They don't ask IUPAC nomenclature better. How do you distinguish acetophenone and the benzophenone? Like that you will get questions. So remember these two very, very, very important. Star mark टिक कर दो आपका टेक्स्ट बुक में दोनों. IUPAC nomenclature all we have discussed here. So here what happened, nomenclature you have to give like this 1 2 3. So 3 methyl cyclic group, no, cyclopentanone like this, isn't it? Right? This is cyclohexane carbonyl. If you don't use benzaldehyde, use carbonyl like this. Cyclohexane carbonyl. Isn't it? This is called what? 1, 2, 3, 4. 4 nitrobenzene, carbonyl, benzaldehyde. Both are correct better. Benzene, carbonyl, benzaldehyde. But use benzaldehyde is better because shortcut it is like this. But when you have more than one carbonyl groups, in that case give number like this 1 2 3. Now this is the parent chain now, because we have how many functional groups? 3 are there here. In that case, now the functional group on which carbon? First carbon, second carbon, third carbon. Now take propane 1, 2, 3 tetrahydride, isn't it? This is node point. Okay. Remember one beta, when CHO is in parent chain, put call that one as al. If CHO is not in the parent chain, call that one as carbonyl. Carbonyl. Right? You have taken carbonyl because it is not in the parent chain. Correct or not? You taken the carbonyl because it is not in the parent chain actually. Now a box is given. All this you have to practice here. All the box with whatever is there, practice the nomenclatures. Now already we discussed this one, the sp2 hybridization, 120 degrees. The pi electron cloud will be above and below. Here the pi electron cloud, here it will be because pi orbitals will looks like sideways overlapping. No, that is the reason it will looks like this. Now when you have some, these structures is already I have taken these structures in the questions which I made here. So you can do this one. Disecondary butyl means how you write disecondary butyl? C double bond O, CH3, isn't it? I'm writing below. CH3, CH2, CH3, CH3, C double bond. Now put this one in this side also. You will get the compound here. Disecondary butyl here. 4-fluoroacetophenone. How you get 4-fluoroacetophenone? Already told you, acetophenone is like this. CH3, C double bond O, pH. pH means I am writing like this, benzene. pH means we can write benzene like this. Now this is the first carbon, second carbon, third carbon, fourth carbon. Put here what actually? Fluorine here. Put here fluorine. This will be the 4-fluoroacetophenone. Now the preparation methods are there here. We'll see one preparation method here. Today only one preparation method. Only 5 minutes we'll discuss the preparation method. But still you have some exercise will be there at the end of the chapter. We're going to see some exercise. Only I think my nomenclatures will be there. So you see that nomenclatures, try to practice the nomenclatures. You see today one preparation method for 5 minutes. We'll take 5 preparation method. Right. I think oxidation of alcohols already we discussed in the properties of alcohols. But again, I will revise this one. Okay. What is that actually? So when you take primary alcohol RCH2OH, when you treat this one with what? PCC or PDC, you are going to get what actually? Aldehyde. This already I have discussed in the properties of alcohol. You check that. If I take what secondary alcohol RCHOH R, treat this one with any oxidizing agent. You can take KMnO4 or you can take any oxidizing agent, K2Cr2O7, or you can take CrO3. Take CrO3 because it is there in the syllabus. You will get ketones. This already we completed. Where in the properties of alcohol? Secondary is giving what? Ketone. Primary is giving what here? Aldehyde. Next, second one, if you observe, this also we completed dehydrogenation of alcohol. In the properties of alcohols, we completed here. See, again, I'm writing here. In this case, what happened? If primary alcohol, RCH2OH, is passed through vapors, these vapors are passed through copper here at high temperature, around what I think 350 degrees Celsius it is. Okay. At 350 degrees Celsius, this converts into aldehyde, RCHO. Again, if I take secondary alcohol, if I take what happens secondary alcohol, RCHROH. Secondary alcohol, if I take what happens, this is with same reagent, you are going to get what? Ketones actually. So this already we discussed in the proper distinguished test of primary, secondary, tertiary alcohols is there. So you just follow that reactions, you will get this one. And from hydrocarbons, ozonolysis of alkenes, hydration of alkynes. This is we discussed in the 11th class itself. So let me again recap this one. Only up to I will take up to here only. This one only I will take here. Okay. From ozonolysis of alkenes here. How it is, for example, you take CH3, CH double bond CH2. In ozonolysis 11th class, I told you O3 in presence of zinc in presence of H2O2, isn't it? Now what we have to do, break everything, put here one oxygen, put here one oxygen. This I have told in 11th class. So you will get CH3, CHO, you got aldehyde, plus this will convert into what? HCHO, formaldehyde aldehyde. In this way we get it. For example, if I take like this, CH3, CH double bond, CH3, if I take. This one, if I take the same reagent I am taking, the same ozonolysis reaction I am taking. This is the ozonolysis I am taking. Now break this bond here completely. Put here one oxygen, put here one oxygen. Now what we get here? CH3, CHO. How many moles we get here? 2 moles. Understood here? So ozonolysis we have discussed in the where? The 11th class, right? Break the pi bond, you will get the aldehydes. Even you get ketones also. For example, if I take this one, CH3, C double bond, CH3, okay, I am taking this one as a CH3 like this. If I take this one, now again break the bond here, put one oxygen here, put one oxygen. Now we are going to get CH3, C double bond O, CH3, this part. And this part we will get like this, CH3, CHO like this. In this way, we are going to get one is ketone, other is what? aldehyde. Understood? So this is about the ozonolysis here. By ozonolysis of alkenes, We are going to get what actually? Aldehydes. Here actually, what is the reagent you are using? Ozone plus zinc plus water, H2. You take H2, okay? H2O you take. And last one here, by hydration of alkanes. By hydration of alkanes, you are also going to get the aldehydes and ketones. Let me see this one. Alkanes. Now, how to do this one? Now, I have taken CS3, C triple bond CH. This is alkyne, propane it is. Now, if you do addition of water in presence of acid, H plus in presence of acid, H2SO4. Hydrolysis reaction. Hydrolysis. This also we discussed in the where? In the 11th class, how to make the product here. Very simple. Now, break this bond. Break two bonds actually. Break two bonds actually. Right? Break two bonds. All the pi bonds. Break all the pi bonds. Now put here what? OH. Put here one hydrogen. Again put here, because once you break one pi bond, you have to put one OH and one hydrogen. So you are breaking two pi bonds. So put two OH groups and two hydrogens. Now what we are going to get here? CH3, C, OH, and one more OH we are getting here. You break this. No, don't break. You break this two pi bond. Keep this sigma bond like this only. Keep this sigma bond like this only. Now this is converting into what? CH3. Okay. Now what you have to do after this one? You have to do like this. The hydrogen you are taking here, you put like this. This sigma bond is shifted over here. And the OH will be removed here. So you are going to get here CH3, C double bond O, CH3. You are going to get the H2. Right? You will get acetaldehyde if you take this product. If you take what happened, HC triple bond CH you take and follow the same mechanism. Break the pi bond like this. Put here OH, hydrogen and hydrogen. Once you do what happened, you will get CH3, CH. Right? So this is the method, isn't it? Here, this one. Hydration of alkynes, triple bond, addition of water in presence of acid, H2SO4 or HgSO4. We'll get what? Different type of. If you take what happened, ethyne. This is ethyne, no? This is ethyne. It's giving what actually? Ethyne is giving what actually? Acetaldehyde. It is giving what? Acetaldehyde like this. Correct? So tomorrow we'll see the preparation of aldehydes, only aldehydes, and ketones completely what happened? Only aldehydes and only ketones. Okay? And Rosenman reaction will come tomorrow. So that is Stephen reaction will come. Therefore, tomorrow class is very, very important. So try to read these topics to itself. Okay. All of you, textbook you have to read the nomenclatures, what we discussed here. Read all of you. Right. You have any doubts now? Any doubts you are having?